Hi guys, today I'm going to show you how to use the Riemann sum to actually look for the area under a graph, right? So we have actually two formulas for that, right? We have the upper limit formula, which is this one right there, right? It's basically the limit as n approaching infinity. We have our sigma sign, right? It's basically like the summation is an addition of a bunch of let's say areas that you add up together to get like a total area, right? So in this case, right, we have our graph right there, which is f of x equals x squared plus 2, right? So we want to look for the area under this curve, which will be this area right there, right? The shaded area. So now we have our boundary, which is from basically 0 to 4, right? And let's say a equals 0, b equals 4, right? So it's the same thing as this a and this b, right? It's the same values. Those numbers, they could change anytime. It could be from 2 to 5. It could be from 1 to 3, 1 to 6, 1 to 7. It doesn't really matter. Those numbers could change based on the function, right? So it's basically this function right here could be rewritten as this, right? It could be the integral from 0 to 4 of x squared plus 2 dx, right? That's just a more simpler way of rewriting that, right? But since we want to use the upper limit formula in this case, then we're just gonna apply that, right? So since we know we have our a, we have our b, let's say we want to cut like small rectangles, right, that go a little bit over the curve, right, since we're using the upper limit formula. Right, so that means that the area that we're going to get using that formula is going to be slightly bigger than the original area that's under the curve, right? So let's say this is our w, right? This is our width. So our width, what is going to be what? It's going to be, let's just write it right there. W is going to be 4 minus 0 over n in this case, right? And the reason why it's over n is because we are basically cutting, an n amount of rectangles, which is an indefinite amount of rectangles, right? If we were asked to cut 3 rectangles or 5 rectangles, then it will just be 4 minus 0 over 3 or over 5. But in this case, we don't have a limit, so we're just gonna set it up like this, right? So we have our w, which is basically 4 over n, right? So now we can plug that into our upper limit formula right there, right? So let's just say it's going to be the limit as n approaches infinity, right? We have our n right there, I equals 1, of f of 0 plus 4 minus 0 over n times I, let's not forget our I, times 4 over n, right? Well, 4 minus 0 over n, but it's just 4 over n. Let me just rewrite this for you guys. Is the limit as n approaches infinity, right? n I equals 1 of f of 4 over n times I times 4 over n, right? So guys, this section right there, right, this right here, this is basically your x value, right? We just call this is our x value. So now, since you have your x value, then the next step will be to plug it into the original function, right? So you'll be able to like solve for the upper limit formula. But today I'm just here to show you guys how to set up the equation, right? So this is basically the end result. This is the equation that we need. The limit as n approaches infinity of basically f of 4 over n times I times 4 over n. So this is how you set up the equation for the Riemann sum using the upper limit formula. The lower limit formula, you could do the same thing, right? But this is where my video stops, guys. So thank you.